Welcome to the lesson on SciPy. In this lesson, we would be talking about SciPy, which is a multi-purpose math stats library. So this has a lot of algorithms from math, stats, calculus, linear algebra, machine learning, image processing, a lot of different fields. So this is a really powerful library. So this page, which you can see, is the reference page for SciPy. The link to this page would be available in the resources tab. So this page has tutorials. So you can use these tutorials to study about any of the aspects of SciPy. It also has references. So these are links to the documentation for each of the sub packages in SciPy. So these are the sub packages in SciPy, and this is the link to the documentation. So you could uh, click on any of these links and view the documentation. I would be talking a bit about each of these packages and then in depth about the ones which are going to be used in this class. So the clustering package has algorithms or clustering algorithms where, so basically clustering is an unsupervised machine learning technique where without label training data, you just try to group data into clusters. So the algorithms for implementing or the algorithms which can be used for clustering can be found in the cluster package. The constants package has a list of constants like pi or epsilon or the other constants. The discrete Fourier transforms package has methods to perform DFTs or discrete Fourier transforms. So this is popularly used in image processing, signal processing. Integration package would have the methods for integration. So if you have taken calculus course, so you would be familiar with these methods. And the interpolation package allows you to do mathematical interpolation. So if you're given a sequence of data and you want to fill in some missing values or you want to add values after the range, you can use this package. Input and output allow you to save and load your data. Linear algebra package. So we have seen linear algebra functions in NumPy. Similar functions can also be done using SciPy. So they can be achieved using the linear algebra package. Miscellaneous routines has a number of general purpose functions or general purpose methods like factorial or loading an image or reading an image, stuff like that. So multidimensional image processing would allow you to perform operations on images. So it is basically used for image processing. So orthogonal distance regression is a method for prediction. So it is a supervised technique. Optimization and root finding. In optimization, what you try to do is try to find parameters for a function which would either maximize or minimize, which essentially means optimize the function. And root finding would allow you to find roots, square root or nth roots. Signal processing has a number of algorithms related to the domain. Sparse matrices. What sparse matrices mean is that uh, they are matrices with a large number of zeros. So such matrices have a lot of different power. So you can use the sparse matrix functions to on sparse matrices. Linear algebra for sparse matrices. So this is, as the name suggests, the linear algebra operations on sparse matrices. Compressed sparse graph routines. So basically what these methods are, repeat on this. Compressed sparse graph routines. So these are graph methods for, or graph based methods for sparse graphs. Spatial algorithms and data structures. So these have data structures and methods for space related data. So someday if you decide to make your own map application like Google Maps, you can use this package. Special functions. So this has a large number of special functions. An example of that is the Bessel function. So a number of special functions which you would see if you take like the advanced math classes. So basically statistical functions. Okay, so basically the statistical functions include the general purpose statistical functions like computing the probability density function or your chi-square and stuff like that. Statistical functions for masked arrays, these are essentially the same as the statistical functions, except that the data structure used is masked arrays. Masked arrays is a special data structure which is provided in NumPy, which can be used to represent data with missing values. So uh, you can compute statistics of such functions or such data. C and C++ integration, these allow you to write glue code to integrate with C and C++. So this is an overview of SciPy or the stuff you can do with SciPy. Uh, Make sure you go through the documentation. You might find so if you want to perform some operations, there is a great chance that it would be provided in SciPy. There are also tutorials up here in the same page, so you might want to check out these tutorials. Uh, Now I would be talking about some functions which are important from the perspective of the class, which are used in the class. I cannot talk about everything in detail, so about SciPy, if you need any of the libraries, you must go through the reference or the documentation.